In this video, we're going to do a couple of examples that deal with parallel and perpendicular lines. So you have parallel, you have perpendicular, and of course you have lines that are neither parallel nor perpendicular. And just as a bit of a review, if you've never seen this before, parallel lines, they never intersect. So let me draw some axes. So if those are my coordinate axes right there, that's my x-axis. That is my y-axis. If this is a line that I'm drawing in magenta, a parallel line might look something like this. It's not the exact same line, but they have the exact same slope. If this moves a certain amount, if this change in y over change in x is a certain amount, this change in y over change in x is the same amount. And that's why they never intersect. So they have the same slope. Parallel lines have the same slope. Perpendicular lines, depending on how you want to view it, they're kind of the opposite. If this, let's say that this is some line, a line that is perpendicular to that will not only intersect the line, it won't only intersect the line, it will intersect it at a right angle, at a 90-degree angle. At a 90-degree angle. And I'm not going to prove it for you here. I actually prove it in the linear algebra playlist. But a perpendicular line's slope, so let's say that this one right here, let's say that yellow line has a slope of m. Then this orange line that's perpendicular to the yellow line is going to have a slope of negative 1 over m. Their slopes are going to be the negative inverse of each other. Now, given this information, let's look at a bunch of lines and figure out if they're parallel, if they're perpendicular, or if they are neither. And to do that, we just have to keep looking at the slopes. So let's see. They say one line passes through the points 4, negative 3, and negative 8, 0. Another line passes through the points negative 1, and negative 2, 6. So let's figure out the slopes of each of these lines. So I'll first do this one in pink. So this slope right here, so line 1, so I'll call it slope 1. Slope 1 is, let's just say it is, well, I'll take this as the finishing point. So negative 3 minus 0, remember change in y, negative 3 minus 0 over 4 minus negative 8. 4 minus negative 8. So this is equal to negative 3 over, this is the same thing as 4 plus 8, negative 3 over 12, which is equal to negative 1/4. Divide the numerator and denominator by 3. That's this line. That's the first line. Now what about the second line? The second line, the slope for that second line is, well, let's take here, negative 1 minus 6, over negative 1 minus negative 2, is equal to negative 1 minus 6 is negative 7 over negative 1 minus negative 2. That's the same thing as negative 1 plus 2. Well, that's just 1. So the slope here is negative 7. So here their slopes are neither equal, so they're not parallel, nor are they the negative inverse of each other. So this is neither. This is neither parallel nor perpendicular. Neither parallel nor perpendicular. So these two lines, they intersect, but they're not going to intersect at a 90-degree angle. Let's do a couple more of these. So I have here, once again, one line passing through these points, and then another line passing through these points. So let's just look at their slopes. So this one in green, what's the slope? The slope of the green one, I'll call that the first line. We could say, let's see, change in y. So we could do negative 2 minus 14 over, I did negative 2 first, so I'll do 1 first, over 1 minus negative 3. So negative 2 minus 14 is negative 16. 1 minus negative 3, the same thing as 1 plus 3, that's over 4. So this is negative 4. Now what's the slope of that second line right there? So we have the slope of that second line. Let's say 5 minus, so let's say 5 minus negative 3. 5 minus negative 3, that's our change in y, over negative 2 negative 2 minus 0. So this is equal to 5 minus negative 3. That's the same thing as 5 plus 3. That's 8. And then negative 2 minus 0 is negative 2. So this is also equal to negative 4. So these two lines are parallel. These two lines are parallel. They have the exact same slope. And I encourage you to find the equations of both of these lines and graph both of these lines and verify for yourself that they are indeed parallel. Let's do this one. Once again, this is just an exercise in finding slopes. So this first line has those points. Let's figure out its slope. The slope of this first line, one line passes through these points. So say 3 minus negative 3, minus negative 3, that's our change in y, over 3 minus negative 6. So this is the same thing as 3 plus 3, which is 6, over 3 plus 6, which is 9. So this first line has a slope of 2/3. What is the second line's slope? So this is the second line there. That's the other line passing through these points. So the other line's slope, let's see, we could say negative 8 minus 4 over 2 minus negative 6, minus negative 6. So what is this equal to? Negative 8 minus 4 is negative 12. 2 minus negative 6, that's the same thing as 2 plus 6. Right? The negatives cancel out. So it's negative 12 over 8, which is the same thing if we divide the numerator and the denominator by 4. That's negative 3/2. Notice, these guys are the negative inverse of each other. If I take negative 1 over 2/3, that is equal to negative 1 times 3/2, which is equal to negative 3/2. These guys are the negative inverses of each other. You swap the numerator and the denominator, make them negative, and they become equal to each other. So these two lines are perpendicular. And I encourage you to find the equations. I already got the slopes for you, but find the equations of both of these lines, plot them, and verify for yourself that they are perpendicular. Let's do one more. Find the equation of a line perpendicular to this line that passes through the point 2, 8. So this first piece of information, that it's perpendicular to that line right over there, what does that tell us? Well, if it's perpendicular to this line, its slope has to be the negative inverse of 2/5. So its slope, the negative inverse of 2/5, the inverse of 2/5 is 5. Let me do it in a better color, a nicer green. If this line's slope is negative 2/5, the equation of the line we have to figure out that's perpendicular, its slope is going to be the inverse. So instead of 2/5, it's going to be 5/2. Instead of being a negative, it's going to be a positive. So this is the negative inverse of negative 2/5, right? You take the negative sign, it becomes positive. You swap the 5 and the 2, you get 5/2. So that is going to have to be our slope. And we can actually use the point slope form right here. It goes through this point right there. So let's use point slope form. Y minus this y value, which has to be on the line, is equal to our slope, 5/2, times x minus this x value, the x value when y is equal to 8. And this is the equation of the line in point slope form. If you want to put it in slope intercept form, you can just do a little bit of algebraic manipulation. Y minus 8 is equal to, let's distribute the 5/2. So 5/2 x minus 5/2 times 2 is just 5. And then add 8 to both sides. You get y is equal to 5/2 x. Add 8 to negative 5, so plus 3. And we are done.